All right, guys, so we're going to be reading the measurement of this graduated cylinder, and its unit is going to be milliliters. We have to get at eye level with it so that we can tell what it is. Right now, I couldn't really tell because I'm not looking at it at eye level. But like Ludacris once asked and once sang, he said, "How low can you go?" And so we really got to get low and make sure we get down there at eye level. And I'm looking at it and I can tell it's between 9 and 10. And then I've got other little ticks in between. So it looks like it's somewhere in between 9.1 and 9.2. And it's a little bit closer to 9.1, so I'd probably call it like 9.12 or 9.13. And as far as giving y'all credit on the tests and stuff, we will have a range. So don't worry about having to get the exact answer. There'll be a range, some wiggle room for you to type in what it is. Now, if all you do is put 9.1, would you get credit? Absolutely not. We have to give that what it measures plus the estimated digit after.
Alright, hey guys, so I'm going to show y'all how to use a ruler when we're in class. So looking at the ruler, you can see all of the different ticks, right? So we want to make sure that when we line this up, we're lining it up with the very first tick on the ruler, not the end of the ruler. Because when we're starting, we start from this tick. So we want to make sure to line it up right against there. And then we're going to move over, right? So we know that it's 1, 2, 3, 4, 5, 6, 7. So it goes fully to the 7, but not fully to the 8. So then we have to count the little ticks, right? So you know it hits 7, we hit 0.5. So then we count the little ones, 0.6, 0.7, 0.8, and it hits just barely past that 7.9. So when we use significant figures, we had to go 7.9, and then here it looks 7.95. All right, so now we have a stirring rod. So we're gonna apply the same rules that we used with the glue stick, right? So make sure that the end of the stirring rod starts at the first tick, not the ruler. So we'll put that there, and then again, we're going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 is the last one. The 20 is the last number that we see that it hits. So it doesn't go to 21. So now we have to count the little ticks. 20, 20.1, 20.2, 20.3, 20.4. And it goes barely past that 20.4. So we add one more sig fig, so it'd be 20.45, let's say.
What's up, guys? Okay, so we are going to try to figure out the density of this marble, okay? But how do we do that? So if you did not know, our formula for density, okay, is mass over volume. So we need to find out how we actually can do that. Now, can I just find the density by looking at this marble? No, I need to weigh it. Now, if you remember from biology, if you ever did this, whenever we weigh it, am I going to just stick this marble on here? No, I'm not, okay? Because 9 times out of 10, it's gonna roll off and then you have an accident. And we know in our lab safety video, we don't just directly do that. So I'm going to put this weigh boat on our scale. You'll notice when I put the weigh boat, it weighs out to be 2.20 grams. Now, if I put that marble on there, it is going to not only include the mass of this marble, but it's also going to include the mass of this weigh boat. So I'm gonna press the tear button so it tears out, not including the weigh boat. I'll put my marble on there, and it'll show that our marble weighs 3.85 grams, okay? So now I have my mass of my marble. I'm gonna come over here so that way I can see what our volume will be whenever I put this marble in there. Now, can I put this marble in here? No, it won't fit. It's not going to work. Would it do any good for me to put the marble into this graduated cylinder? No, because when I drop that marble, it's not going to rise. We're not really going to be able to see a difference in the level of the water after. Okay, so we are able to read the volume of our graduated cylinder right here, and y'all should have already read it on your own, but let's see what we are at. We are looking at about 52.1 or 2, 3, give or take, like we said, okay? Now, when I drop this marble in, okay? Notice the level of the water changed. We would come back here and read our level now. We are at about 54, no, probably at about, 54.2 or so. Yeah, I'd say probably 52.2. So I'm gonna then take both of those values and I will do our final minus our initial to get our volume, and then we would plug that into our density formula to figure out what that would be.
All right, guys, we have some examples of sig figs up here on the board for you. And we chose a bunch of different examples that each has different implications. And the most confusing things with sig figs is probably the zeros, because y'all learned last class that sometimes the zeros are significant, but sometimes they're not. So obviously the 4, the 3, and the 2 in this first number, they're all significant. Anything that's not a zero is always significant. However, this 0, because it's after a decimal following other sig figs, that would be deemed significant. So we have all 4 digits here that are significant. I'll put it in a different color so it stands out that one has 4 sig figs. When y'all watch the other videos and see like answer keys that we'll post, we'll put sig figs as just being S.F. Now, number 2, almost identical to the one above, except now it's got a comma instead of a decimal. So again, the 4, the 3, and the 2 are all significant, but because this 0 follows all of those significant figures and there's no decimal, that would not be a significant figure in this case. So this one only has 3 sig figs. All right, now moving down to the bottom, we gave you a different example. We have 0 at the beginning, before the 1 and the 7, and then we've got another one following. So like we talked about on number 1, how that 0 is significant also makes this 0 significant. However, because this 0 is before the first actual sig fig of 1, that is not a significant figure. So this would have 3 significant figures. Another thing you'll see us do as teachers, we will underline which figures were considered significant. So if that helps out, I'll do it right now. Now looking at this one is kind of similar to the second one that we did, except there's a decimal this time. So again, the 4 and the 3, always significant. That 0 on the previous example was not significant, but that was because this one did not have a decimal. This one does have a decimal placed very strategically to show you that that 0 is considered significant. So all 3 of those digits are considered sig figs. Now, the last one. We wanted to choose an example of where you have zeros in between some sig figs. So again, we always know that if it's not a 0, it's significant, but also zeros that are in between other sig figs are considered significant. So we got 1, 2, 3, 4, 5 sig figs. And again, the reason those last ones were not significant was the same reason it was not significant on this example.
Okay, so we're gonna do a couple examples of multiplying and dividing and with sig figs, because that's super important. So what I always do and what you'll learn is, for this first example, obviously we are multiplying 4.2 by 3.79. So what I'm gonna first do is figure out how many sig figs we have in both of those, okay? So we have 2 right here, and then it's showing that we have 3. Now, the rule is whenever you do this, to determine how many sig figs for your answer, it's always by the least amount of sig figs you have. So this 4.2 is representing that we have 2 sig figs. So our answer has to have 2 significant figures, okay? So here we go. I'm going to plug this in my calculator. 4.2 times 3.79, okay? I'm going to write everything out so that way I can figure out what my answer will be, okay? So I'm going to do 15.918. I'm not gonna box that because that's not my final answer, okay? How many sig figs do we need? 2, okay? So right now we have 15.918. This 9 right here is going to increase our 5, okay? And make this be 16. That 16 is our answer. We have 2 significant figures, okay? Now, moving on to our second example showing division. We have 7.835 divided by 2.45. We have 3 significant figures here. We have 4. Our answer needs to have 3 significant figures. Okay, when I plug this into my calculator, 7.835 divided by 2.45, okay? That gives us 3.197, okay? Now, we need 3 significant figures. This right here, this 3.19, that's not our answer because this 7 is going to move over and increase that, giving us 3.20. I know a lot of y'all, and I don't say y'all, meaning everybody, but most students will want to just put 3.2 and be like, well, that 0 doesn't matter. It does matter because we need to have 3 significant figures. So that, if you wrote that on your quiz or your test, that would be incorrect. This is what you need to write, 3.20. This shows us we have 3 sig figs.